start our topic about composition and resolution of force at a point. Let me go through the introduction first. To start with, composition of force can be defined as combining two or more force that acting at the same point into a single equivalent force that produce the same effect. Since the two forces can be combined to give the resultant force, therefore, by reversing the process, single force can be resolved or broken up into two components. This reverse process is known as resolution of force. Usually, a force is resolved into the components which are perpendicular to each other. If there are more than two forces involved, this method is used in finding the resultant force. Next, let's continue on how the term used in this topic. As we can see, figure below shows a single force that can be defined as F. By applying the parallelogram rule, the force is resolved into a pair of perpendicular components, namely the vertical components Fy and horizontal component Fx. In the diagram below, we can see that a force had been drawn, and from the drawn force, we can determine their vertical component and horizontal component. And as you can see in the note below, the horizontal component is equal to F cos theta, while the vertical component is equal to F sin theta. Let's continue to the first question of this topic. For the first question, a boy pulls a cart with a force of 70 Newton and at the angle of 55 degrees above the horizontal. Find the horizontal components and the vertical components of the force. As you can see in the diagram on the left below, we can see there's a graph, and in the graph we need to draw a force drawn by a boy and state the angle, which is 70 Newton and 55 degrees respectively. So to calculate the horizontal component, as you remember from the last slide, we need to determine the horizontal components, we need to use the formula that is F equal to cos theta. And for this question, we need to write it as Fx equal to 70 cos 55, because 70 is the F and 55 is the theta, and the horizontal component force is equal to 40.15 Newton. And for the vertical component, we need to use the formula F equal to sin theta. So to calculate the vertical component, Fy equal to 70 sin 55, which is 70 is the force, 70 is the F, and theta is the 55. So the answer for the vertical component is 57.34 Newton. Why the horizontal component and vertical component is positive respectively? Because the horizontal component is being pulled to the left and the vertical component is going upward.
Okay, now let's talk about question 2. A climber pulls a backpack using a rope with a force of 100 Newton at an angle of 50 degrees from the vertical. Determine the components of the force in the X direction and the Y direction. So we have to find the horizontal component and the vertical component. For the horizontal component, Fx equals to negative 100 sine 50. We have to put the negative because the force is on the left. So the answer is negative 76.60 Newton. Next, for the vertical component, Fy equals to negative 100 cos 50. We have to put negative because it is downwards. So the answer is negative 64.28 Newton. Okay, now let's talk about question 3. A crane lifts a load using a cable that exerts a force of 90 Newton at an angle of 70 degree from the horizontal. Determine the horizontal and vertical components of the force. So we have to find the horizontal component and the vertical component. For the horizontal component, Fx equals to negative 90 cos 70. We have to put the negative because the force is on the left. So the answer is negative 30.78 Newton. Next, for the vertical component, Fy equals to 90 sine 70. So the answer is 84.57 Newton.
Okay, question 4. A man pushed a heavy cat load with boot, exerting a force of 150 Newton along the handle at an angle of 50 degrees from the vertical. Determine the horizontal and vertical component of the force. Okay, for the horizontal component, we need to Fx equals to 150 sine 50. So Fx we got 114.91 Newton. Okay, for Fy, we need to take negative 150 cos 50. So for Fy, we got negative 96.42 Newton.
Let's continue to the resultant from the sum of components section in this topic. So for the fifth question, 4 workers are pulling a heavy crate at the same point using the ropes in different direction as the following diagram. So for the question is to find the horizontal components and vertical components of each force and find the resultant force. So let's continue to the question number 5. For the first question of the fifth question, the question is to find the horizontal component and vertical component of each force, which means we need to find the horizontal component and vertical component of each force in the graph. As you remember from the past slide, the graph, the angle and the force has been stated. So the first force, to calculate the vertical component, as you can remember from the past slide, the formula is F sin theta. So for the vertical of the first force is 65 sin 60, and we got the answer is 56.3. For the horizontal component, we use F cos theta, and we insert the value, and we get the answer 32.5 Newton. Why both of the force is positive respectively? It is because the horizontal component move toward right and vertical components going upward. So for the second force, the horizontal component we get 68.9 Newton and the vertical component is negative 32.1 Newton. For the horizontal component, the force is positive because the horizontal components move toward right and the vertical component going downward. And for the next force, the vertical component is equal to negative 36.8 Newton, and the horizontal component is equal to negative 39.5 Newton. Both of these force is negative respectively because the vertical component force going downward and the horizontal force is going to the left. And for the last force, which is the force is the force of the vertical component is 70.9 Newton, and the horizontal component is negative 55.4 Newton. The vertical component is positive because the vertical component force going upward. Meanwhile, the horizontal component force is going to the left, and because that's why the value is negative. So for the second question of the fifth question, we need to find the resultant force. To find the resultant force, first we need to find the total horizontal component. And to do this, we just need to sum all of the vertical component of each force that we calculate. Only the horizontal component. And the value we get, the force we get is 6.46 Newton. And the total vertical component is also, we need to find the sum of total of vertical component, which is 58.3 Newton. The resultant force, to calculate the resultant force, we need to square the total horizontal component and vertical component. And we square root the total of square horizontal component and vertical component. And the resultant force, we get 58.6 Newton. And also the direction is theta equal to tan inverse 58.3 over 6.5, and we get the direction 83.7 degree on the first quadrant.
Okay, for question 6, we have two child pulling rope that are tied to a metal ring in the middle in the open direction as the following diagram. We need to find the horizontal component and vertical component of each force and the resultant force. Okay, first we need to find the horizontal component and vertical component of each force. Okay, for force A, horizontal component is 6 Newton and for vertical component is 0 Newton. Okay, for force B, we need to take negative 8 cos 60 and we get negative 4 Newton, and for vertical component we need to take negative 8 times with sine 60 and we get negative 6.93 Newton. Okay, for C, we need to take for horizontal component negative 10 times with cos 50 and we get negative 6.43 Newton, and vertical component we need to take 10 times with sine 50 and we get 7.66 Newton. So for the resultant force, okay, first we need to calculate the total horizontal component, and we get total horizontal component equal to negative 4.42 Newton, and total for vertical component we got 0.73 Newton. So the resultant force we need to take square root of negative 4.43 square plus with 0.73 square. So we get 4.49 Newton. For the direction, we get negative 80.64 degree.
Okay, now for the conclusion. We live in a 3D world where we almost never push or pull things in perfect straight lines. everything is at an angle. By figuring out how forces either team up, composition, or split apart, resolution, humans have basically learned how to hack physics. It's the reason we can build safe bridges, design fast cars, and move heavy stuff without hurting our backs. Ultimately, it is all about taking the energy we have and steering it exactly where we need it to go.